All right, thank you all. So again, this talk is a little different from what you see outside. So this is kind of like a bait and switch, but I hope you stick around. So the story behind it is that we started collaborating with Databricks very recently on MLflow. So we decided to repurpose this time slot to talk about this instead. But in case you're curious about what's happening with Spark R, I'm going to give like a 30-second update in just a little bit. So quick intro for those of you I haven't met. I'm an engineer at RStudio, working on whatever is popular at the moment. So that used to be big data and Spark, and then now that's kind of mainstream, I tell people I work on AI. I also care about things that matter at a job, like putting models into production. And then also the fan of wine, if you want to chat about that during the breaks, hit me up. So as promised, Spark R update. So literally a couple of days ago, 0.9 hit CRAN. And we now support structured streaming with Shiny integration. And then the monitoring of jobs in the IDE. So now you can actually, in the middle of a job, hit the stop button in the IDE, and it's not going to corrupt your RStation or the Spark application. And of course, Kubernetes, because Kubernetes is cool and doing stuff at scale is cool. So I'll refer you to the blog post and the updated documentation. And if you're a fan of Carrot and Tidy models, check out the new experimental integration of Parsnip with Spark R. Okay, so back to this talk. So if you went to Matei's keynote earlier today, you probably saw some of the motivation that went into the project. But I'll just do a quick recap, and then also from the perspective of the R user. So when you're putting a model into production, it involves different people and different expertise. So sometimes that there's going to be friction, and that's exacerbated by the fact that people have different backgrounds, so they don't tend to speak the same language, and this is sort of a stereotype, but I thought I would call it out. So our users tend to be more of the math stats types, and that they picked up programming during their coursework or in their research, and then they weren't usually formally trained in software engineering. So you're in these conversations, and sometimes people won't say it, elephant in the room, but they're thinking about it, and then they think, oh, the R data scientists, they don't know anything about software engineering principles or model hardening. So that's why we really care about empowering the R user to sort of facilitate their collaboration with production engineers. So, and Python users on the other hand, I was going to say something about that, but I'm not. But really, we're cool. So, it's in our one of our goals is to support Python at RStudio as a first-class citizen in some of our commercial products. So regardless of what language you're using, there's always going to be some friction between data scientists and the engineers who are going to put these models into production. And this type of conversation, they change every year. Is a little different, but microservices and whatnot, they tend to be pretty popular these days. So. And then on top of that, there's so many different ways you can do things. So then what do, right? Like different companies have invested a lot of resources like putting these types of platforms together. So another theme is reproducibility, and it's not just an academic issue. So if you run an analysis at work today for a specific report, and if you're not careful, tracking what you're doing, putting things into source control, and all of that, future you in 3 months might not be able to reproduce the numbers that you got today and send to your boss. Right? So that's another thing that we want to keep in mind. And depending on where you are, you might say, oh, these are problems that have already been solved. And specifically, if you work at a big tech company, you're like, oh, easy, no problem. We just follow the framework that we put together, and then we're all set. But then what about for the rest of us? What if you're not at a big tech company? What if you typically don't have a culture sort of to build really large-scale machine learning frameworks? Then what do you do? So then you can look at what's out there, and then usually it's a balance between picking the thing that's deprecated and then the thing that doesn't really work yet. And that's kind of okay, right? Because if you're on the cutting edge, that's sort of what you have to do. But then the real problem, I think, is the lack of standardization. So if everyone's taking pieces together from different ecosystems, then it's kind of hard to get help, right? You can't go on a mailing list where everyone else is using the same framework, because they're not. So there are efforts in different language ecosystems to sort of tackle these problems, and these are some of the things that I've seen just off the top of my head. I'm sure there are more in the R ecosystem, but today we're going to talk about MLflow, and then why we think that it's a good bet to sort of invest in this open ecosystem to do the end-to-end machine learning lifecycle. So, of course, we won't solve everyone's problems with just one framework, but I think there are enough commonalities among different companies that we can sort of find the common denominator that's going to help everyone. And then for the problems that are specific to each team, we can have some guidance on like what do you do? What are some things to think about, right? And then hopefully that's going to help everyone accelerate their timeline to production. So MLflow, to recap, it has 3 components. And then these can work independently. You can use one without messing with the other 2 if your project or your workflow doesn't require it. I guess the caveat here is that if you're running a project, you will be using tracking, but we can talk about that when we do the demo. So basically, MLflow tracking, what it does is it helps you keep track of what you're doing. For each model that you run, captures performance metrics, parameters, and other things that you care about. The project component bundles your project environments so that you or others can reproduce your results afterwards. And then the model component allows you to package your scoring function, which would encapsulate your model for serving either locally or on the cloud. So let's jump to the demo. And I'm gonna make this a bit bigger. Okay, can we see okay? Maybe I'll just pop this out. Okay, all right, there we go. Okay, so risky live coding. All right, so library MLflow. So the package is not on CRAN yet. It is currently under review, but if you want to give this a shot, I'm going to share a link where you can grab it from GitHub. So the way to do something, we're going to demonstrate the tracking API first. So let's say you have a parameter that you've just defined. And I'm going to do this like really generally without even talking about machine learning, and you can think about what you can do with it. You can, for example, say you want to track this foo variable. Then you can say, OK, I'm going to log this parameter. And then what's going to happen in the background is we're sort of starting a service that's going to help you keep track of things. So we can do another log param operation. And then now that we have a couple, we can see what's going on. So then when you do a logging application, an experiment run, which is sort of the main entity in MLflow tracking, has been created for you. And then you can inspect it and then see what sort of information is there. So right now we just have, OK, the thing started a few seconds ago, and then these are the parameters that we tracked. It has a unique run ID and whatnot. And then if we go back, all right, there we go. And say we want to have a metric. So let's say we build our model, and then we got some root mean square error number that we want to track. We can say log metric. And then you can go back to your run in the UI, and then you see that, OK, now we have a metric that we started to track. And then it has a little nice a plot that's going to show what happens over time. So of course, with only one, it's not very interesting. So if we do this a few more times, and then I guess one application here is maybe you're tracking your performance over the number of iterations of the specific algorithm that you're using. So then once we do that, you see that, OK, over time, over the number of iterations, what happens to your performance. And of course, if you are getting negative RMSE, you have bigger things to worry about. And then you can also log tags, so any arbitrary information you want about this specific experiment run. So you can say something like trending data cutoff or something like that, and then you can say, oh, this was, we did a time split, I say, the end of last year. So then you can do that, and then, of course, it's going to show up there. And then the cool thing is you can really log anything you want. So if let's create a text file. Let's say something that sounds cool but doesn't make sense. AI-powered blockchain adversarial Kubernetes. Sorry, that sounds pretty hypey. All right, so then of course we have to say, OK, let's have a text file. So now we got our output.txt file. And then we can say we want to log this artifact to our active run. And then we can come back to see that it has indeed been recorded. And then depending on the file type, you can preview what's the specific artifact in the UI. So once we're done, we can say MLflow and run. And then we can see, OK, what was the duration of this particular run? So that's one way to do it. And then the idea about this is that we want to be not intrusive. So you shouldn't have to change your workflow too much. So all of the MLflow stuff is you can use it, and you don't have to use it. So you can just log the stuff that you care about, and then the rest of the code should be pretty much the same. So another way you can do this, if you don't want to keep remembering that you have an active run going on, you have to do an end run. You can use a context manager using a with block. So basically, if you do something like this, then what this will do, and I'm going to change some numbers around, is that it's going to end the run for you at the end of the block. So you can do something like this, and then if we go back, we can see that in this case, it has automatically, the run has automatically been ended. And again, we can see some tracking information. So this is how you track stuff, and you can get creative and then start thinking about what type of thing you want to include. And there's also a notes section in here that supports Markdown, so you can say something like horrible model, and then some code just to show that Markdown works. So pretty cool, I think. All right. So let's move on to the second component, which is the project component. So here we have a more realistic example on GitHub. So here we're actually getting some data, wine quality data, which is always interesting. So we're trying to predict wine quality using an elastic net GLM, doing a trend test split like a good data scientist and all of that. So then the idea is that you can just specify where your project is, and then what the entry point, and in this case is an R script, and you can pass some parameters to it. So you can say, okay, I want to run this project with this entry point, and then these are the parameters that we want to try. So these are the alpha and lambda in the elastic net, and maybe you want to try a different one. We'll do that. So what is doing in the background is it's actually pulling the code from GitHub and then running the project. And then if we go back to our UI, you can see that they have been ran and they have been logged, so you can see the metrics and then also the parameters associated with the metrics. So then this really helps you to keep track of what you've done in the past and then what worked well and then what didn't. And then in this specific example, it also gives you the exact git commits of the state of the project, so you can go and browse the repository at that specific point in time. And then there's also this run command that you can give to someone who doesn't really care about R or anything like that, and then you can run this project from the command line. And let's see if that works. Well, in a live demo, there's always something that doesn't work. So maybe this is it. OK, so let's move on. All right, so I guess it started to run, but it ran into some issues. But that's a project component. So again, the idea is that you can run a project from any language really without knowing all of the details of the implementation. So next, our final example, we're going to talk about the model component. And here we're going to build a simple Keras model to make some predictions on our favorite data set, iris, predicting flowers, of course. So we got our model. We're going to get some data, do some training, look at our loss and accuracy over time, blah, 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 and then save the model. And then let's say it's the next day, and then you want to load the model back into memory. We provide utilities for that in MLflow, and then you can make predictions with the model that you saved. And then if we wanted to deploy this locally to test it before deploying the model on a server, we can do that. So then now we got a service running at this endpoint, and then we can say, okay, so these are the values that we want to pass to the scoring service, and then we get back some class probabilities. Okay, so again, this is just a local serving example, and for different model flavors, we're going to work on R interface wrappers that's going to help you deploy models to different cloud platforms and for different machine learning libraries, such as H2O or Spark ML that's being serialized to MLeap, that kind of thing. So I'll be putting all of these on GitHub, but I think that that wraps it up for us. So basically, it's a cool project. So definitely check it out. Share your feedback and use cases, and then if you have issues with the R API, tag me and my colleague in the GitHub issue, and then we'll get on it. It's going to be on CRAN soon, so you should be able to grab it really easily. And again, I'll be sharing everything that I've done today. So we got time for a few questions.
Any questions? Going once, going twice. We got a question.
If you can hear me, I was just wondering how this MLflow stuff going to integrate with, let's say, Cloudera distribution of Hadoop, or where we have a cluster manager and we're not working on a single laptop. We have a cluster and we have a data scientist and parcel of stuff like that.
Oh yeah, good question. So I showed the UI here, right? So this is running on my laptop because I wanted to minimize dependency on Wi-Fi. But then what you would actually do in a team setting is you would stand up your own MLflow tracking server. And then it doesn't matter whether you're running your models on the cloud, on a huge cluster, or on your laptop. You simply basically point to this tracking server, and then anyone can, you can set up permissions, right? So you can say, okay, your team can publish your results on this tracking server, and then other people can access it. And I think that there's facilities within MLflow to do authentication too.
So my question is similar to the previous one. So with MLflow, I can in some way then package my model, and perhaps I can run on a different environment. About all the dependency, do I have to have R installed on all the nodes in the cluster if I wanted to run an MLflow model package, or in some way the container is containing also all the dependencies to run the model?
So it's going to depend on the language that you're using. So for Python, I believe I forget the name of the file, but they capture the conda environment of all the dependency. And then for R, what we're doing is you can choose to use pack rats. So there's a function, MLflow snapshot or something like that, that basically captures the exact versions of all the packages that you're using. And then when you run the model, you can choose to basically recreate the environments of the data scientists that created the model. Does that sort of answer the question?
Yeah, ask me. Okay, thanks.
I think one over there.
Is it also possible to track code differences in the UI? So, for example, if you have changed a line in the code and then compare from one.
Oh, so like diffs basically.
Yeah.
Not off the top of
I just
my
saw
head,
it
but
track the git commit.
yeah,
So
you can go to the git commit, and now I guess we'll have to think about like which diff you're tracking, right? So if you're running the model, so there's a couple of things at play here. So one is the project, right? And then the other one is the parameters that you pass to the specific project run. And then the way that you will track those hyperparameters that you're passing is by using the logging functions. And then the git commit that I showed, that's basically for, I think I closed it down. It's for the commit for the project, if that makes sense. So I don't think there's a way to include the diff. I may be wrong, but basically for the diff on the project going from commit to commit, you can just go to the repo to check that out.
Yeah, I was mostly thinking for the local script that you have, if there's a way to track
the local script. You can log it as an artifact.
Okay, but you have to manually.
Yeah, but usually when you're running it locally, the idea is that you only want to keep track of the things that you care about. You might not want to keep track of the whole thing. So then for the things that you care about, you will say, okay, MLflow log param this. And all of this is text, of course, so you can put it under source control.
All right, last question.
Hey, I was just thinking, it's called MLflow, but it could be used for anybody in this room who's doing performance tuning on Spark, because if you're just running a normal SQL query and you record as the output the time that it takes, you can get a nice plot where you change the number of executors and things. And also in finance, people run risk models, so they use Spark to distribute data to a risk model and then collect the results back. So it can be used to capture results from input data sets and output data sets. So it's not just it can be used for lots of things.
Yeah, that's a great point, and then that's one of the reasons why I started out doing like really general stuff instead of doing the machine learning experiments. So like you said, you can use it to come up with like your value at risk measures or whatever, and then have a log of everything that you've done, and then keep track of how long your overnight run took, and then with this, if you do it if you do it properly, it can. I can't imagine why not. You can show it to regulators and auditors and say, okay, we've done the proper testing, and this is the code that we used.
All right, thank you, Kevin.
Thank you all.